So we're going to solve quadratics by graphing. Let's create a scenario. We're looking at measuring the profit margin as a function of the product, number of products we're going to make, and it equals to, and now what happens is the cost of producing is going to be a negative number, and it's going to be a function of how many units times the units. So this is one modeling situation. And then we have the profit. Every time we make a product, we're going to have income of 10 times that number of product. And then we have a setup cost. Now, realistically, it's not $3, $10, $3, but instead it would work out to be something like in thousands of dollars. So we'll put this in $1,000 range. So it works out to be the profit every time we sell one. Let's see, what should the one be? Let's make it, the product we're going to choose is an electric bicycle. So a plug-in bicycle. And it's going to be the cost, setup cost to manufacture these is going to be $3,000. And the cost of each item is going to be $10,000. And then this factor here is every time we make one, it's going to cost something to make it. The more we make, the more it increases in cost. So every time we make another one, it's going to cost, again, squared that amount. So that the reason for this is things like the factory space, we would need more to produce more. We need running costs that would cost more, and you have overtime and so forth. We would have an extra support. The more and more we make, we need more and more support. That's why this goes up like this. This is a typical modeling situation for finance. So what we're going to do is solve this by graphing and be able to put together the pieces that would be needed to do that. So let's put the picture here. What's the first thing we notice? What's the first, sometimes the easiest one, is if we produced none, we would have, this term would be 0, this term would be 0, we would have -3. So that would be our profit of -3,000. So we can graph that on the graph here at -3. Now we don't want to do that. We produce nothing. We've made no profit. So we're looking at a profit, and we're going to optimize the profit. What's the number of product we want to make that would maximize our profit? So the next critical piece we would do is, let's go with axis of symmetry. Where is it that the axis of symmetry, the equation for the axis of symmetry is x equals -b over 2a, and our b coefficient is 10. So -10 over 2 times -3. And that works out to be 1.6 repeating. So that's the number we would put here. So 1.6 is right about there. 1.6 is our axis of symmetry. X equals 1.6 repeating. And that's the axis of symmetry. So axis of symmetry. Okay, so that's a critical point. Now, how do we find what would be next? The next point would be the vertex. Let's find the vertex on this one and be able to use the axis of symmetry. So vertex would be the production level at the 1.6. So we put 1.6 repeating, -3, 1.6 repeating squared, plus 10, 1.6 minus 3. And that equals, works out to be 5.3. So at producing 1.6 bicycles, and let's say that this is per month, this is critical. So this is the production level. I should write that over here. This is, X is production per month. Okay. So if I were to produce 1.6 repeating bicycles per month, that would give us a optimal profit of $5.3 thousand. And that would be the profit, not the expense. The expense of producing 1.6 would be 1.6 times 10. But this would be the profit because we also have some other expenses. So the margin here, 5.3, and that vertex would be right here. The vertex, and that point is 1.6 repeating, 5.3 repeating, 5.3 repeating. So you would have that profit. So we have a point here, a point here. Let's pick the point, picking a random point here. Let's say let's pick 3. What is the value of this function when it's 1, 2, 3? So I'm just going to put another point on here. So we have an additional point in order to graph the quadratic. So value when it's 3 would be negative 3 squared minus 10 times 3 minus 3. Well, that equals 927. Oh, this is plus. Plus 30 minus 3 is 0. Well, that's a 0, the function. So let's mark that as a 0. And how far away is it from here? That would be 1 1/3. So we go 1 1/3 here. 1 1/3 would also be 1/3. So this is 3, 0. This would be 1/3, 0. These are the two functions. I found this by the fact that this is an axis of symmetry. Go the same distance to here is from here to here. So this distance is equal to this distance. Okay, so we can sketch the graph now because we know much of the information. So let's sketch the graph. That's a decent sketch. Okay, so that's solving quadratics by graphing. On your own, try this problem and pause the video and then we'll solve it. Okay, you pause the video. Let's graph the critical points on this one. First thing I want to do is find when x equals 0. When you put in x equals 0, what is the value for y? 2, 0 squared minus 3, 0 minus 9. That would be minus 9. Okay, so putting that on the graph. 3, 4, 5, 6. Okay, that's a point on the graph. Okay, so the next one is the axis of symmetry. Finding the axis of symmetry. X equals negative b over 2a. Negative b, negative and negative 3. 2 times 2. Negative, negative 3, that would be a 3 over 4. Positive number. So let's stretch this out a little bit. I'll mark this with blue. 1, 2, 3. 3/4 right about here. So axis of symmetry, x equals 0.75. Axis of symmetry. Okay, so finding the vertex. Vertex is the same x value. So we know the x value of the vertex. We need to plug that in for y. X is equal to 0.75. And that would be equal to 2 times 0.75 squared minus 3 times 3/4 minus 9. And that equals a value of negative 10.125. So if this value was 9, this would be 10, just not too much lower. So right about there, that number, label that number as 0.75, comma negative 10.125. That's the vertex. Now, one more point, a valuable point. What are the zeros of that function? Or can we find it? So picking a point, let's pick the value 2 and see what we get and then graph that. Y when x equals 2. So right here, so 2 times, let's see, this would be a 2 squared minus 3, 2 minus 9. That would work out to be a 8 minus 6 is 2, minus 9 is minus 7. So we can put that on here. So this is 7 right about here. So if by symmetry, we can go 1 plus a quarter, we go 1 plus a quarter, it's at 7 right here. And that would, let me label these points so we have confusion. And this would be 2, negative 7. This would be the value negative 7 mirrored about the axis of symmetry, negative 7. And this would be how far over 1 and a quarter more would be negative 1/2. Negative half. Negative 7. Okay, so that looks like a pretty good amount to graph. We could graph that, sketch that graph. So something like this. And that's it.